Good morning, students. I am Pramod Jain, your computer science teacher, and this is our seventh and last video related with the unit number 1, computer systems and organization, and second video related with number system. Once again, I want to just show the tables. That means the octal equivalent of binary as well as the hexa equivalent of those binary numbers. Now, binary to octal. How to convert a binary number to octal? And three examples are given here. The very first example, convert 100 111 to the base 2 to octal. Here we have to group the entire binary numbers from that starting from the LSB, least significant bit, to MSB, most significant bit. So LSB means towards the right side of those numbers. We have to group into 3 numbers each. That means 3 numbers a group, starting from the LSB, starting from the right side towards the left side. So first we have to group that 010, then we have to group that 111. Only after that the first 3 numbers 100. So 100, that side is called that MSB, most significant bit, and that the 010, the last 0, that's called the LSB, least significant bit. And now the octal equivalent of that 100, 111 and 010 is written. That is 472. So 100, 111, 010 to the base 2 is equivalent to 472 to the base 8. Now another example. Convert 110, 1011, 0 to the base 2 to octal. Again starting from the right side. Just group into 3 numbers starting from the LSB. So 110, then 010, then only 2 numbers are there, 11. 11 is there. We cannot group into a group of 3 numbers. So what to do? We have to add extra zeros. And here in the second step you can see that one extra 0 is added. It's underlined, you can see that. Now the octal equivalent of that. So 011 is equivalent to 3, 010 is equivalent to 2, and 110 is equivalent to 6. So the answer is 326 to the base 8. Now the third example. Convert 1011.0101 to the base 2 to octal. A fractional number. Again the integer numbers as I showed you earlier, starting from the least significant bit till the most significant bit. But here in the case of fractional numbers, we have to start from the right side. Here for example, the fractional number start like this, 0.0101 to the base 2. So first we have to group the first 3, not from the last. We have to group the first 3, a group of 3 numbers. So 010, then comes only 1. So what we have to do? As we have done earlier, we have to add some extra zeros. So here we have to add 2 extra zeros. And that becomes 100, 100. And now the octal equivalent of that. 010, the octal equivalent is 2. 110, the octal equivalent is 6. Then point. Now 010 again, the octal equivalent is 2. And 100, the octal equivalent is 4. So the answer will be 26.24 to the base 8. Converting binary numbers to hexadecimal numbers. Here, instead of grouping 3 numbers a group, we have to group it based on 4 numbers a group. We can see an example. Convert 101011 010 to the base 2 to hexadecimal. So again starting from the LSB, from the right side, least significant bit. 4 numbers a group we have to group. So 1010, now 1011, now last just 10. So how to compensate that? You have to add 2 zeros there. Now the hexadecimal equivalent of that 0010, 1011 and 1010 is written there, 2, 11 and 10. And the 11 and 10 can be written in a different manner like BA. Hexadecimal number 0 to 15. or we can say that 0 to 9 and A to F. So 10 10 111 010 to the base 2 is equivalent to 2BA to the base 16. One more example is given there to show how to convert a fractional number to hexadecimal number. In the same manner, we have to group based on 4 numbers a group. And the answer is written there. Octal and hexadecimal to binary. 4 examples are given. On the left side, octal numbers to binary, and on the right side, hexadecimal numbers to binary. And the very first example, 472 to the base 8 to binary. 472. So the binary equivalent of 4, that is 100, and the binary equivalent of 7 is 111, and that of 2 is 010. And that you have to write jointly. And you will get the answer. 472 to the base 8 is equivalent to 100, 111, 010 to the base 2. Now how to convert an octal fraction to binary? 3.1 to the base 8 to binary. So octal equivalent of the binary equivalent of 3, that is 011, and the binary equivalent of 1 is 001, and it is written jointly with the help of a dot. Now the right side, converting the hexadecimal numbers to binary. Here the group will be of 4. That means there will be 4 binary numbers. 9, how to convert 9 to binary? 1001. What about F? 41 and 20010. And the answer is written there. Like the other one, a fraction to binary, a hexadecimal fraction to binary is written down. Character or string representation. ASCII code. ASCII, American Standard Code for Information Interchange. The ASCII code is used for the transfer of alphanumeric information between a computer and the input-output devices. A computer also uses it internally to store the information. The ASCII code is a 7-bit code, and so it has 2 raised to 7, that is 128 possible code groups. This is more than enough to represent all of the standard keyboard characters as well as control functions. There is an extended ASCII that uses 8 bits to represent various characters. It can represent 256 characters as opposed to 128 characters of ASCII. ISCII code, Indian Standard Code for Information Interchange. This is an 8-bit code capable of coding 256 characters. ISCII code retains all ASCII characters and offers coding for Indian scripts also. Thus, it is also called Indian Scripts Code for Information Interchange. Unicode. Unicode is developed as a universal character set with an aim to define all the characters needed for writing the majority known languages in use on computers in one place, to be a superset of all other character sets that has been encoded. Unicode provides a unique number for every character, no matter what the platform, no matter what the program, no matter what the language. Encoding terminology. Encoding scheme. It is a predefined way of converting information, character by character, in a machine intelligible code. Code space. It refers to all the codes that an encoding scheme uses to represent characters. For example, ASCII uses 0 to 127 characters or 0 to 127 numbers. Code point. The code point refers to a code that represents a single character from the character set represented by an encoding scheme. Code unit. It refers to unit of storage, that means number of bits used, to represent one encoded code point.